What if we can train a robot brain inside of the video game? We have powerful AI models like SmolVLA and game engines like Unity, but can we actually connect them? I spent days hitting the wall trying to do it, but finally found a way. I will show you how we can set up the robotics simulation environment in Unity, how we can collect a dataset, convert it to LeRobot format, train our SmolVLA model and run its inference back in simulation. Ready? Let's go! But why do we want to use Unity as a robotic simulator, while it's not actually a robotic simulator, and while there is plenty of other actual robotic simulators? If you want to go straight to the action, you can skip that part by going to that timecode. So before choosing the Unity, I tried few other simulators, and there's my opinion on them. ROS plus Gazebo, the standard in industry. Well, if you're a beginner, you will even not able to install it. You'll spend few days fighting some installation problems and trying to not destroy your operating system, and still there will be something that will not work with ROS. So respect your time and mental health. Do not touch ROS. NVIDIA is succeeding. Just refuse to work on my machine. Can't say more. There's two other simulators that actually could worth your attention and may work for you in my opinion, the Webots and Skill. Both of them have plenty of advantages. Webots has many of predefined robots and scenes. You can also write code inside of it in any of the most popular programming languages. Skill is the cool open source project which especially could be good for you if you are familiar with the gym simulation environment. So why did I actually ended up with Unity? Well, so first of all, I didn't need to learn any new particular robotic simulator, knowing which will be useful only inside of this particular robotic simulator. Unity is a popular thing that could be useful for you anyway. If you will not succeed in the robotics, we can always switch to making video games. Second, it's a giant community. If you have any problem in Unity, there's for sure plenty of other peoples and AIs that know how to solve it. And third reason is an ability to create any custom scene you want. In Unity you can use ton of free assets with furniture and different items and create on base of them actually any of the scene you want. You can configure your scene, your furniture inside of your, let's say, house that will be a robotic simulation environment any way you want. Well, in other simulators, very often you just convicted to one of few scenes available and you can't do anything more with this. Let's go to Unity and let's start creating our simulation environment. Our task will be to teach a robot arm to shoot different objects like cans. I know, in all the other tutorials they teaching you how to make all that different boring manipulation tasks taking different objects and so on, but we will do something much more interesting instead. I took a robot arm from this preset, link in the description. Please let me know in the commentaries if you want to see also how to import your own robot inside of the Unity simulation. Also downloaded a few free assets with furniture from the Unity asset store, and that way set up my shooting range. Next, created scene manager script. The script is needed to control our scene to randomize positions of our furniture, for example, on every training episode. All scripts are available on GitHub. Next, we create our main script to control a robot, where we read and set up positions of its joints. Also setting up our camera. In that concrete task of shooting cans, one camera is perfectly enough, but for most tasks it's recommended to have at least two. To train our model, we use so-called imitation learning technique. It's the same when you're learning to dance. You need to watch a few times how your teacher doing a move to repeat it itself. Same here. We're recording many episodes, 50 is a good start, where we're showing to the model how it should behave. Let's create then a function for auto aim that will be our teacher showing how to shoot the target. No, not like this. This. I'm obviously not writing all the code by myself, but using a clean coder AI coder framework, one of my previous projects by the way. You can find link up here. Now we can run our simulation and enjoy watching how pre-built policy shoot the target. All we need to do now to collect a dataset is for every simulation step to save the file with join states, camera images, and action vector. Action vector is a list of commands our robot receives from the policy about how to change every joint position. Both join states, which are angles of our joints, and action vector elements should be normalized to -1, 1 range. From the data, we'll need to create dataset in LeRobot format. The format contains parted files with our joint data, MP4 videos, our camera, and a lot of stat files. But do not repeat my mistake here. Do not try to save all that files manually. The problem with LeRobot is that they are providing you with an amazing guides how to run a dataset collection on their hardware using their script, then to how to train a model using yet another their script, or interfere that model on their hardware again using yet another their script. Problem is that without that understanding what's going on in that code, you hitting a wall when trying to work with something else than their hardware. It took me many days to prepare code for manual dataset recording in Unity, code that saves all Parquet and MP4 files according to LeRobot dataset format, and that dataset still wasn't working because it still wasn't compatible ideally with their format. Finally, I came up with much simpler idea. I used Unity to save all the raw data from the robot joins in the JSON-L formats, and then using another Python script, I converted my JSON-L based dataset to the LeRobot compilant dataset. That approach finally started to work. Both the dataset recorder file and the Python script converter you can find on my GitHub. Link in the description. Now we have our datasets, it's time to function a model. We'll use train.py utility from LeRobot. First, clone the repo and prepare virtual environment and run the train command with arguments specifying the policy types, pass it to a dataset, its name, and other stuff. 20,000 training steps took about 2 hours on my RTX 4090, and our model is here. What's next? How we can make Unity to use it to control our robot? We can't make actually policy interference directly in Unity, that's why we'll use the client-server architecture. Unity will send observation to the Python server, which actually runs our policy and calculates the actions. LeRobot actually has a policy server script in their repo, but we will not use it. The reason is the gRPC connection method they're using, which I wasn't able to set up in the Unity. Instead, we'll create our own server and client scripts, which will communicate over a WebSocket. A much easier way. Scripts also on GitHub. And the moment of truth, let's run our server and simulation, and our policy hits watermelon. Often. At least sometimes. When a model works somehow, but not perfectly, it may be a good idea to revise and improve the dataset. I mentioned that in some of the episodes, my target is overlapped by some other object. So, model in fact learns not to shoot target, but learns to shoot that other object here, and let's improve it. And another problem I found is that our episodes have fixed length. So after our target been hit, it's still few seconds after it that actually nothing happens, but the model learns, from that time still. To solve it, I improved the dataset collection script. Now it discards the episode if first object to hit was not our target, and finishes it just after the target hit. So I collected dataset again, this time better dataset, and again trained a SmolVLA. The quality of inference improved. Now watermelon got hit more often. Okay, let's move to the next experiment. Now, I recorded the dataset of the robot having different tasks. To shoot a watermelon, shoot a can, shoot a milk carton, or shoot a battery. Theoretically, SmolVLA has that task field in the dataset, allowing it to train model for different tasks. But how I realized in practice, it did not work. I tried different number of examples, different number of training steps, but still didn't manage to make our policy learn more than one task simultaneously. So my conclusions of that project. Unity seems to be a good choice as a robotic simulator since its ability to create actually any scene, any environment in it, in difference of many other robotic simulators. However, setup in it could be a little bit more complicated because in Unity we are not coding in Python, but in C#. So that's why we need that additional step in dataset conversion or that client-server architecture while interfering our model, where server is Python and client is the Unity. SmolVLA seems to be a good and relatively easy model to train once you already figure out how to do it. However, despite of the producer intent, we are not able to train more than one task within it. So obvious question appears. What is the point of using SmolVLA model? I thought the whole idea behind of it is that idea of the generalization over different tasks here. So, but while our model wasn't able to do more than one task simultaneously, we can do the same thing with classical ML policies, which are much more lightweight and then work faster. That's all for today. I hope that video has been useful for you and you successfully trained your SmolVLA model. If you have any problems, write me in the commentaries. I will be happy to help. I'm really reading and answering all the commentaries here. Please also like, subscribe. It will again really help that channel to grow. And see you next time. Bye.